Oh, what's up, Super World? We're going to keep going with organic today, and we're going to start with what are called aromatic compounds. Right, and these are compounds where the parent molecule is benzene, and I've made you a model of benzene. We'll talk a little bit more about it in a minute. Right, so let's just bring this over here. Alright, aromatic compounds. Number one, so the parent molecule is the benzene molecule. And benzene is C6H6. And the general formula of the aromatic compounds are C to the N, H to the N. And if you look at the molecule itself, if we look at the benzene molecule, they alternate, double, single, double, single, double, single. Okay. Now we could flip this, and it would be double, single, double, single, double, single, right? But this is actually in resonance, okay? So we don't actually see a double bond here and a single bond here. So this is going back to last semester, right? But one of these electron pairs is delocalized, right? So it can go around here. So instead of seeing a double bond and a single bond, we see like a bond and a half and a bond and a half, right? And then those two electrons are actually free to move through around the structure, which gives it some electrical properties, okay, that are pretty important. So when we draw benzene, okay, 1, 2, 3, 4, 5, 6. So we could have double bond, single bond, double bond, single bond, double bond, single bond, right? And then you'd have one hydrogen coming off of each of these. Or we could go the other way. Double bond, single bond, double bond, single bond, double bond, single bond. Right? So it's really just flipped. Right? But like I said, we don't see either one of these. These are in resonance. So these are resonance structures. So these are our benzene rings. All right, now, we represent these in a couple different ways. All right, you might see something like this. All right, so that's an example of a benzene ring. One way we could do it, and you might also see this, where you have the double bonds written like that. Okay, so both of these are acceptable. You'll see both of them, right? And then here are your resonance structures. All right, now what do I want to do next? Alright, we can put side chains off our benzene ring. Alright, so we can take our benzene ring and we can take a hydrogen off and we could put a bromine atom on. Or we could put a chlorine atom on off these side chains. Actually, we could put a methyl group on here. Could put a methyl group on here like this. Right? Actually, you can put a long carbon chain coming off this end. Actually, we could put a carbon chain off this end. All right, so there lots of things can come off this benzene ring. Right, so how would we name something like? Well, let's start simple. How would we name something like this with a methyl group? Right, so in this case, we would have our benzene ring. And I'm going to use this. And then coming off here, we have a CH3 group. Now, since when we go to use these rings, the side chain is going to dictate how we number it. Okay, so we're going to number this aromatic compound so that the carbon has the lowest possible number. So, okay, if we only have one, this is going to be the 1. Okay, so this would be 1, and it doesn't really matter which way we go because there are no other ones. So this would be 1 methyl benzene. Alright, well what if we have, I don't know, why don't we put both of these on? Okay, what if we have something like this, where we have a methyl group and a bromine and a fluorine? Okay, how would we name this? Alright, well let's draw it. So we got our benzene ring, right? And we have a CH3 group coming down here, right? And then the bromine is coming off of here, and then we have a chlorine here. Right? So now the very first thing we have to do is we have to number. Right? So we could number this 1, 2, 3, 4, 5, 6. Let's see here. We could go 1, 2, 3, 4, 5, 6. Or you could number it 1, 2, 3, 4, 5, 6. All right, now, in reality, I probably wouldn't number it any of those ways. All right, so when we're putting these in order, I guess it doesn't really matter. Would I number it this way? Well, I would definitely go counterclockwise. In reality, it doesn't matter which one you start with. Okay, for our purposes, it's not going to matter which way you start with, because okay, so let's number it. Let's name this with going counterclockwise. So we're going to go in this direction. So this would be 1 methyl, 2 bromo, 3 chloro, benzene. So let's draw it again. Is there another way I could have numbered this? And the answer is yes. All right. You wouldn't start from here because you would have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So you'd have 1, 2, 6, or if you went this way, it would be 1, 2, 6. All right, which is too high. But if we did this, 1, 2, 3, 4, 5, 6, then we would have 1 chloro, 2 bromo, 3 methyl benzene. Okay, they're the same molecule. All right, and either one of those would be acceptable for our purposes. Later on, when you take organic, all right, there's some differentiation between these two. All right, but for now, if you name this 1 chloro, 2 bromo, 3 methyl benzene, okay, I would give you credit. So they're really the same molecule, right? You're just switching up where these side chains are coming off of. Okay. All right, so it really doesn't matter to me which way you do it. Just make sure they have the lowest possible number. Now, actually, benzene can be a side chain. It's really not a side chain, but it can come off. It can come off and be a functional group. And when it does that, when it's a side chain, or when it's a functional group, it's called a phenyl group. it's called a phenyl group. So let's look at a couple. So we can have a carbon chain with this benzene ring coming off of it. Okay. This right here would be a side chain, okay, and this would be called a phenyl side chain. So to name this, we'd name the longest carbon chain 1, 2, 3, 4, 5, okay, which is a type of pentane, all single bonds, and this would be 3 phenyl pentane. This is telling us that it's a benzene ring. Oh, we're not on the, sorry, we're not on there. Okay, so this would, the phenyl tells us that it's a benzene ring. And then it's coming off a pentane. Right? Now, we can have benzene coming off a cycloalkane. So we could have something like this. So this is a cycloalkane, okay, and this is a phenyl group or a benzene ring. So we'd name this. We would name this. Right, so this would be cyclopentane, and it would be phenyl cyclopentane. Right, and you could put a 1 in there, but it has to be a 1, right? So this would be phenyl cyclopentane, and that's our benzene ring. So our aromatic compounds are ones that have this benzene ring in it. Okay. All right. Other than that, you really just, the only thing you're going to have to do with these aromatics are you're just going to have to recognize them, and you're going to have to be able to name them, and that's about it. All right. So nothing too crazy. All right. So the next thing I want to run through real quick is I want to run through the organic reactions. So let's run through some of these run through the organics. Yeah. I don't want to spend a ton of time. You do need to be able to recognize them and use them. Tell me what they go through, or you'll write some of these things. So, right, some of them you already know. So the first one we're going to talk about is combustion. And we've already done this one. All right, so here we're burning, usually it's hydrocarbons. Okay, we're burning hydrocarbons. And remember, our products of combustion when you're burning a hydrocarbon are always going to be carbon dioxide, water, and energy. So let's do the combustion of propane. So what's happening in your gas grill? Right, so if we write propane, we got C3H8. We're burning, we're adding oxygen. It's going to produce carbon dioxide, H2O. It's exothermic, so it's going to produce a bunch of energy. Okay, and then if we balance this, let's see, we're going to need 3 of these, we're going to need 4 of those, and we're going to need 4, 6, we're going to need 5 of these. Okay, so here's the balanced equation of our combustion reaction of propane. Okay, so this one's nothing new. All right, you should be able to handle writing combustion reactions with hydrocarbons. All right, so that's our first organic reaction. The second one we're going to deal with is something called substitution. So when we're dealing with substitution, this is the replacement of a hydrogen atom. On a saturated hydrocarbon. So that means this has to be with an alkane. Okay, this happens only with the alkanes. All right, so let's come up with a substitution reaction. So let's use ethane, C2H6, and let's say we're going to substitute with diatomic chlorine, right, and it produces C2H5Cl and HCl. Now, I think it's hard to see this way, see what you're doing or what's happening here, so let's go ahead and use structural formulas. So there's my ethane. We're adding a chlorine atom. So what's going to happen here is that one of these hydrogens comes off. It doesn't matter which one. Let's say this one. So this one's going to come off, and he's going to come over here with chlorine. This chlorine is going to substitute onto there, right? So we end up with we go from a hydrocarbon, okay, to an organic halide, usually. And you could do this for, you could use fluorine, you could use iodine. There's lots of things that we could substitute onto that saturated hydrocarbon. But substitution has to be with an alkane. Right? And I'll show you why next. Because if you try to add something in an alkene or an alkyne, it's not going to do substitution, it's actually going to do addition. So in addition, we're adding to an unsaturated hydrocarbon. And this can be an alkene or an alkane. Alkene or an alkyne, sorry. We're going to do a couple here. So let's say, I don't know, let's say we have ethene, and we're going to add hydrogen, and it actually produces ethane. All right, so let's look at it. So ethene has a double bond. We're going to add diatomic hydrogen. And this time what happens is the double, or in either case, the double or the triple bond, depending what you're starting with, it's going to break and it's going to form a single bond. And then one of the hydrogens is going to sit here, and one of them is going to sit here. So we end up with our ethane. All right, so this is a typical question, and we'll do this a lot. All right, in industry, we do this a lot. If we have an unsaturated hydrocarbon, we want it saturated. All right, we'll do an addition reaction. We'll add hydrogen to that unsaturated hydrocarbon, and it will make a saturated hydrocarbon. All right, so if you ever get a question like, how do you convert an alkene to an alkane or an alkyne to an alkane, it's an addition reaction adding hydrogen. All right, now it doesn't have to be hydrogen. don't know, let's say that we have propene. And I don't know, how about diatomic bromine? Right. So in this case, it's going to do the same thing. Right. That double bond is going to break and become a single bond. One of the bromines will come over and sit here, and the other one will sit here. So we end up with that's another example of an addition reaction. Right, so, and it can happen with a triple bond also. I've done it twice with a double, but it can happen with a triple too. And it's the same thing. It does the same sort of thing. Okay. Alright, so that's our addition reactions. The next thing I want to quickly talk about is fermentation. So this is number, what are we on, 4? Fermentation is actually a simple reaction. Okay, so this is how we make alcohol. This is how we make the alcohol in beer and wine and all our spirits like bourbon and vodka and all these. Okay, so it goes through a process called fermentation, and we're going to start with a 6-carbon sugar. And it will always produce 2 alcohol molecules and carbon dioxide. Okay. So now, usually what we start with is glucose, okay, which is a 6-carbon sugar. Okay, so we start with C6, H12O6. And this actually goes through decomposition. And it decomposes into 2 ethanols. Okay, this is our ethanol. Okay, so that's our alcohol. And it produces carbon dioxide. Okay, so this is actually what fermentation is. Right, so this is the process that we do to make this alcohol. And that's all there really is to fermentation. Right, but you should definitely be able to write it and recognize it. Okay, it's producing those alcohols. Let's see. Let's do dehydrogenation next. And this is also an easy one. This is kind of the opposite of addition. Right, so this is removing hydrogen from an alkane to produce an alkene. So we can go from propane to propene, and it produces hydrogen gas. So it looks like this. Right. 2 of these hydrogens are going to come off, and when it does, it forms a double bond. And it produces hydrogen gas. Now, actually, this is a pretty big reaction. We use a lot of hydrogen, and there's not a lot of hydrogen in our atmosphere. Right? So we actually have to make it. Right? So we make this hydrogen gas, actually a lot of the times using our alkanes. Okay, so we'll just take this alkane, all right, we'll do a dehydrogenation reaction, okay, and we'll turn it into a double bond to get this hydrogen. Right, and then we can use this hydrogen for all sorts of different things. Right, so we can use it for fuel. There's a lot of things we can use hydrogen for. Right, so this is called dehydrogenation, and you start with an alkane, and it produces an alkene. All right, couple. Let's deal with, what number are we on? That was 5. This is 6. We'll quickly talk about saponification. So in saponification, we start with an ester. It reacts with an inorganic base, and it will always produce a soap and alcohol. Alright, now this one's pretty easy to recognize. Now, an example of an inorganic base. I know we haven't talked about acids and bases yet, but you should remember that NaOH, okay, a base is something that produces OH minuses. NaOH is the typical inorganic base that we use in saponification reactions. This is how we're making, yes, soap. This is the stuff that we clean ourselves with. All right, so it makes a soap. All right, now, let me give you an example. All right, so we need an ester. So let's use this. We'll use a simple ester. So this would be methyl ethanoate, and we're going to add a base, an inorganic base, and let's use NaOH. So let me show you what happens. All right, this is kind of like double replacement, sort of. I mean, it's not called double replacement, but it's the same kind of idea. Okay, so the sodium hydroxide splits here. The ester splits there, and this methyl group gets added to this guy, and this sodium gets added to the end of that oxygen. So we end up with Na-O-C double bonded O. Okay, this is our soap. And we get our alcohol, and in this case we would get methanol. But you'll always get some sort of soap, and you will always get some sort of alcohol. And it's the same reaction happens no matter what. All right, so the ester always splits on the right after the oxygen on the alkyl side. All right, and then this splits, and then you just put them together. So this is how we make soap. All right, and it's pretty easy to recognize, and I would expect you to be able to write these. Right, number 7. Is called esterification. And esterification is how we make esters. Right, now remember, our esters are those fragrant aromas. Okay, this is how we make perfumes. Okay, we do esterification. It's how we make the smells in a lot of our deodorants. Okay, for those of you that you like those scratch and stiff stickers. Okay, those are generally esters on those stickers, right? So how do we make an ester? Well, we're going to start with an organic acid, and we're going to react it with an alcohol, and it will always produce an ester and water, okay, which is what we want to get this ester out of it. All right, so let's go ahead and do one. We'll do a simple one. So let's say that we start with ethanoic acid. And we're going to add, we're going to react it with ethanol. And put the OH group here just for ease. And when this reacts, this hydrogen of the acid will come off. The hydroxyl group of the methanol will come off, and these come together to form water. And then these are going to join. Okay. So let's go ahead and read across here. So we'll start with this CH3 group. And then we got a C with a double bonded oxygen. Then we have an oxygen group. This hydrogen came off with the water, right? And then we put this group on over here. Okay. So this would be an ester and our water. Okay. And this would be ethyl ethanoate. Okay. It's a pretty simple way to actually make our smells.